Okay, so that was in that year, 34% of them got it correct for this answer, which really goes back to how important it is to really understand those type of questions. And notice it's always about the 15 and above is when it gets a bit hard in terms of your multiple choice. I always think that for a multiple choice, if you're an average student, you should be trying to aim for 15 out of the 20. 3/4 of it, you want to aim to be able to get 15 out of 20 multiple choice questions correct, and then you're on a good roll there, because the last 5 or 6 questions generally they're a bit more abstract and you have to be able to think about it. Normally my suggestion in exam technique is you would do the multiple choice, get your 15, and those last 5 questions that are abstract, move on, because if you spend too much time, you're wasting time now. Move on to the extend response questions. Do as much as you can, the ones that you know, and the ones that you can't, there's no point sitting there because you're probably not going to figure it out. And even if you think you did, you might not get the mark. If you take your chances and go back to these 5 questions, it's more likely that you can get this mark than it is for the extended response. So that's the technique. I would suggest do multiple choice first, then you extend it, and go back to any that you were iffy in your multiple choice, because it's more likely you can do process of elimination. You have a higher chance of getting 1 mark than you would for an extended response that you're not really sure that you're going to get. Okay, so that's my suggestion. But anyways, we'll work on exam techniques towards to end of term 3 when we start doing practice exams. Here we go. So this question, if you had an attempt at this one, I'm not sure if Specialist does this or not, but I'm going to it's called integration by parts, or like manipulation, or by recognition. There's a lot of terms for this. Hands up if you've learnt this in Spec. No? So the idea is that it always starts off like this. If this is the hint that it's integration by recognition or integration by manipulation, is that they always ask you to derive first, and then in the second question, they will ask you to integrate something in methods that we don't normally do. Okay, so this one, we normally integrate cos x, we normally integrate x, but we do not integrate x times cos x. And so integration by manipulation is you're going to use your first part in order to answer the second part. Okay, so I've got the solutions here, as in I try to write it out. So you're using, the first part is just product rule, differentiate it, and you get sine x, x cos x, and that's the key part. You see, in your derivative, you have what you're looking for, which is x cos x. That's why they're asking you to find the derivative of this in the first step. In your second step, what you have to understand is if this f of x, if you found the derivative, f dash of x gives you that. Okay, so that means if I then take the derivative of x sine x, which is this, we know it equals to this, right? That's what we just did. Then that means if I now anti-diff both sides, technically the derivative and then anti-diff cancels out. True, because you derive, you're moving forward. Anti-diff, you move back. Yeah, so I said derive it and anti-derive it. So you get x sine x, because these two, when you anti-diff, you get x sine x is equal to the integration of sine x plus x cos x. And the nice thing about this is you can split up the integration, and now this is what you wanted. That's what you wanted. And this is why we call it integration by recognition, because you can see what you want. And or it's called by manipulation, because you're going to manipulate this equation such that you can get what you want. So how do you get what you want? If you minus both sides by integration of sine of x dx, then what happens is you're left with integration of x times cos x is equivalent to the left-hand side, and that you can solve. You see, because you do know what the anti-diff of sine x is. Okay, and that's why it's in that process. So the only part I wanted to describe was what I was doing here. Okay, why was I doing it and what I was doing here? That's called integration by recognition, and I'm not sure if Spec does that or not. But then after that, I showed you, and in the next slide, I actually show you the full working solution to what I was doing. Okay, so you can follow that and watch that. But I want to move to average value function. So do have a look at that one. That is a nice one. I don't see it coming up as often, but it does come up in your SACs in the previous years. It might not come up this year, I don't know. But it's worthwhile just knowing how to do that, because if it does come in an exam, as soon as you derive, And then the next part is an integration of something that you don't normally do. It's a big hint that this is how you're going to be doing it. Okay. Anyways, please do have a look at this slide or the previous PowerPoint. It does tell you, it shows you the working solution, how I did it. Okay. I try to color code it for you to see as well. Anyways, here we go. Average value of a function, which is this one. One simple concept. It's the last dot point of area study 3, where you're going to use average value function to answer a application question or so. Okay. Now, this is your theory. Okay. It says that if you've got a curve, okay, so if you've got a curve, and the area under the curve, how you normally would solve it is this. You'd say the area under the curve is equal to the integration between a to b of f of x dx. That's what you've been learning so far. That tells you the area under the curve. Okay, so I'm going to write here area under the curve. Whatever it equals to, I don't care. Okay. What the average value function or the average value function is trying to describe is it's saying that between a to b, somewhere in this interval, there exists an x value that they call c, an x value between that, between a and b. That x value will give you a y value such that you can draw this rectangle. So it gives you this height. Can you see that rectangle they're trying to draw here? This rectangle they're trying to draw. I'm going to try to draw that. They're saying that such that you get this rectangle, and that rectangle has exactly the same area as your actual area if you integrated it between a to b. So that's what I'm trying to say here. I'm trying to say that there is an area of a rectangle such that both the areas are equal to each other. So if I draw it again, just on a blank spot, let's just say I did this, and from, let's say, A to B, let's say the area was 10, okay, hypothetically. If I said, oh, the area was 10, what they're saying is somewhere, if we were to draw, keep the same width, so the width is still this, they're saying somewhere a C value, any C value, that it will give you an area. So you can see this blue rectangle. They said that there is a C value that exists between A to B. Whatever that C value is, it gives you a certain height for the rectangle, and that height will give you an area equal to 10. That's what it's saying. Okay. So if that is true, then what they're saying is this area, you can manipulate it, and you can say, all right, I want just a rectangle to have the exact same area. What is the height? That's what you're looking for, and that's the average value. That's what they call the average value. So if I took off every little notation I have here, C is anywhere. C could be anywhere, but the point is C will give you this height. This is called the average value. That average value is just describing the height of the rectangle, so that when you multiply by the width from A to B, it will give you the exact same area as integration between A to B of f of x dx is what it's saying. So what I wrote over here is I said, okay, well then that means area of rectangle's length times width. Well, the length is always going to be between A to B. And to find the distance between A to B, you find the difference between them. Yeah, so if I said this was 10 and this was 7, then you say the distance is 3. So you would have done 10 take away 7. Yeah, so that's why the length is B take away A. And then your width is actually your height. And they're saying that a particular value of C, when x equals C, you get a height. This is your height. So length times this width will give you the area of a rectangle such that it equals exactly the same as the area under the curve between A to B. Okay? And therefore, if you rearrange this whole equation, if you're trying to find the average value, because that's what this topic's about, the average value, if you divide both sides by B minus A, and that's what they've done here, that's your formula in your sort of textbook. And I didn't want to just give you the formula, because then you find it's bizarre, it doesn't make sense. And the theory behind it is they're just saying there's a rectangle, equals to exactly the same area as under the curve. That's all they're saying. Okay? And your goal is to find that height. Okay, so that's the only one concept I need you to take. If that makes sense, that's all I want you to take. This is literally, I need you to understand. Because if you understand that, then all the questions I'm putting up there should all make sense. You should be able to decipher which one is true. Even the hardest question, 2013, in that question there, you should be able to look at it and say which ones would definitely not be the answer, which ones were. Okay? It's just that one concept that they're trying to test. Did you understand there is a rectangle with a height C, okay, height f of C, such that it gives you the exact same area as the area under the curve? Okay? Now, let's do a quick example so that you get a good feel of this. Okay, so I wrote over here, in almost every year since 2006, I haven't actually checked prior to 2006, but I wouldn't be surprised if it is in 2005 and 4 and 3 for the average value function. There's always one question there, but the question is whether it's going to be difficult or easy. Okay, here we go. Let's do, this is your textbook question. So it says, find the average value of f of x equals x squared for the interval of 0 to 2. So what I want you to understand is, okay, you've got an x squared function, it's a quadratic from 0 to 2. So if I were to draw this visually, I'm just saying this. Actually, I'll just remove that working solution. 0 to 2, so say 2 is here. If I asked you to find the area under the curve right now, you would say the area under the curve is integration between 0 to 2 of x squared dx. You would then tell me that, you know, any diff of x squared is x cubed on 3, and it's between 0 to 2, and you use fundamental theorem of calculus, you sub 2 in and sub 0 in, so you get 8 on 3, 2 cubed is 8, minus 0 cubed, which is 0, and that gives you area 8 on 3. Okay? When they say find the average value, they're just asking you, find anywhere, so I'm going to use a red pen just so you can see, anywhere, there might be a C value somewhere such that if I drew a rectangle right now, that height and this width, the C width, that should give me, from this width, that C value, from this width, it should give me an area exactly 8 on 3 as well. So whatever this f of C is, average value, if I took the area of the rectangle, it should equal to 8 on 3. That's what I'm looking for. So now I know that the base is currently 0 to 2, so that's 2. So 2 times something has to equal to 8 on 3. That's what you're really looking for. You're looking for that number, 2 times something equals 8 on 3. Now you can easily do that just algebraically. You can say 2 times something has to go to 8 on 3, and then, well, x equals to divide both sides by 2, 4 and 3. See, logically, I can actually tell you the answer just by using my theory that I'm trying to tell you. Yeah? But if you wanted to use a formula, it's okay to use a formula as long as you understand what you're doing. You see, the formula is exactly the same thing. They're just saying 1 over b minus a, because that was the interval, that was the width. So 2 minus 0 is 2, and then that's the area. That was the formula. Now if I plug it all in, it works out to be half times 8 on 3, and it's exactly the same thing. But you see the difference between the two, when I draw it and show you on the right hand side, it makes sense. It has a theory behind it. But if I showed you through formula, there seems there's this gap. You're like, all right, if I just plug it into the formula, this is the answer. So I don't want you to just plug it in. I need you to understand what you're doing here. Because if you understand the right hand side, then the left hand side is fair call. You can use the left hand side if you want. But I need you to understand the right hand side. That's the concept. Okay? So that's the question. You got area of a rectangle. You could say, 2 times 4 on 3, and it's to prove that area of a rectangle, if this was a height of 4 on 3, whoops, what's happened? Oh no, my pen again. Anyways, there we go. So that's what I was just trying to say. So we're just trying to say the area under the curve, if we do a 4 on 3 is your height, times your width, it should be the same area as the area under the curve. Cool? Okay. Now let's go with the first two easy questions from your sheet, if you've already attempted it. Question 2010 and 2012, That was in the 60%. So that means that most of the people understood how to do this. Okay, so I started off easy, and you can see that it is an easy question. Now, if you look at that, you're going to use the calculator. I want you to find the average value for each of those functions there. Okay, average value of the function. Same thing, you've got a function, it's between 0 to pi. You're trying to find the average value. You got the formula, you already know the formula. Actually, while you guys have this sheet, I'm just going to restart this computer so I can use the pen. Do question, VCA 2010 and 2012, and then I'll guide you through the next two that is slightly harder. So that's in your 50s, 50% and 40%. And the last one was in the 29%. Okay, all students getting it right. I'm just going to restart this.